Hi everybody, my name is Neeraja Rentichintala. I am a Director of Product Management on AWS Analytics. Today I'm delighted to have my co-speaker, Ronnie James, who is a Senior Director of Business Intelligence at Charter Communications, who is going to walk us through their journey with AWS and Redshift. This is our agenda. First, I will start with a brief introduction on the trends that we see in the modern data warehousing. Then I'll walk through pretty much in deep dive with respect to the recent innovations in Redshift and also cover some of the exciting launches that we have done at re:Invent. I have a very brief demo. Then Ronnie is going to walk through the Charter Communications journey. There are broadly 4 trends that we see when it comes to the modern data warehousing. The first, the data lakes, data warehouses, and machine learning use cases are converging. Customers really want to bring all their data together. They want to do SQL and Spark analytics on top of it and also build machine learning and generative AI applications. The second trend is near real-time analytics. Customers want to bring data from their operational stores, transactional systems, into analytical stores as soon as it is generated. And this helps them to be really proactive with respect to their operations as well as creating innovative experiences for their customers. And when you have all this data together, ease of access is really critical for broader adoption, as well as having robust security and governance controls so that you can ensure that the right users have right access to the data. This is important for data democratization. As many of you know, can I get a show of hands on how many of you actually use Redshift currently? Okay. As several of you might know, Redshift was launched as the first enterprise-grade, fully managed, petabyte-scale data warehouse more than a decade back at this point. Since then, we have kept pace with customer innovations on Redshift so that we can help customers to really expand the horizons of the analytics use cases. And today, customers across all verticals, across all industries use Redshift and different use cases. These are data warehouse migrations, modernizations, self-service analytics, near real-time analytics, machine learning, some of the newer use cases like data sharing and monetization. Some interesting metrics. We have tens of thousands of customers that are using Redshift today, processing exabytes of data collectively per day, and tens of billions of queries per week. And some of our newer, very popular features like data sharing and serverless, we have tens of millions of queries per day issuing through data sharing. And we have billions of queries executed across thousands of customers on Redshift serverless. So when it comes to product roadmap and how we think about kind of where to focus on, there are broadly 4 focus areas. From day one, we have been kind of laser focused on price performance. So we want to make sure we do all the important things so that you can get best value from the system and also be able to scale with the number of users and the amount of data. The second innovation point, I would say, is really converging the data lakes and data warehouses so that we can enable Lakehouse architectures. The third one is simplifying ingestion and being able to enable near real-time analytics. Last but not the least, making sure that the data that is there in your data warehouse is available for building more contextual, more relevant generative AI applications, as well as use Gen AI to improve the user productivity on Redshift. So Redshift has made significant strides on the product in the past 12 months in 2024. We have over 100 features that have been delivered. These span data management, security, performance, serverless, integration with other services, region expansion, and more. So in this session, I'll walk through some of these important feature set and talk about how they could be useful for your use cases. Let's start with the price performance. So Redshift offers up to 3x better price performance than the alternative cloud data warehouse systems. This is a benchmark that we do on the standard TPC-DS. And our goal with performance is not just giving individual workload performance, but also scale the price performance as you add more workloads, add more users, so that your costs are predictable. So one of the common patterns in Redshift customer fleet is this dashboarding applications. These are low latency, very small queries coming at very high concurrency. And we have done a lot of improvements in these areas Redshift offers up to 7x better throughput per dollar compared to the alternative cloud data warehouse systems. So we continuously monitor our fleet to see what are the right performance features that we should develop on. We have shipped a lot of performance enhancements just in the last 6 to 9 months. I'll highlight a couple of things. The first one is really improving the first query response times for dashboarding queries. So we have done a lot of optimizations on our query execution so that the compilation overhead is much smaller for the first query response times. We have improved our data sharing performance. So compared to 2023, the data sharing performance for the first queries is 143 times faster. So it's a significant 146 times faster, significant improvement year over year. And also when your data is continuously updated, it's up to 4x faster. And we have improved our autonomics algorithms so that the sort keys, distribution keys are generated much faster, they're much more smarter. On the system performance, we have introduced RA3L instances. These are smaller instances. So if you are a Redshift customer that is still on kind of the legacy DC2L family, this is our strong recommendation is to move to these newer instances that offer compute and storage separation. We have onboarded Graviton onto our serverless fleet, which offer, again, seamlessly up to 30% better price performance. So a lot of innovations on the performance that are happening behind the scenes and automatically are made available to you at no extra cost. When it comes to performance of Redshift, it's not just about single cluster performance. Thousands of customers have deployed Redshift in a multi-cluster architecture using Redshift data sharing. With Redshift data sharing, you can share live and transactionally consistent data across multiple Redshift data warehouses. So our customers have deployed Redshift data sharing in a couple of common deployment patterns. One is like a hub and spoke, where you bring all your data into a data warehouse. Then you have a set of analytics clusters. One could be for a dashboarding, one could be for a data science workload, and another could be for ad hoc queries, exploratory queries. And you can keep separate compute that is sized for its own price performance requirements. And they can all access the data from this central environment. So this is kind of the hub and spoke architecture. Another key architecture pattern is like a data mesh, where you have different business teams, each have their own warehouse, but they need to share and collaborate on data sets. So data sharing is available within an account, across accounts, and even across regions. And data sharing is also integrated with AWS Data Exchange so that you can work with third-party data pretty easily. Data sharing builds on Redshift managed storage, which means that as a customer, when you are leveraging data sharing, you are getting the compute storage separation. So you get the compute isolation. There is no resource contention, so you don't have to stuff multiple workloads onto the same compute. And the other benefit of data sharing is chargeability. So you can, because the compute is different, you can do chargeback in a multi-tenant environment. So today we are excited to launch a new capability of data sharing. It's called multi-data warehouse writes. So when data sharing originally launched, it supported only read workload isolation, which means that I can take, as I mentioned, the dashboarding workloads, analytic workloads, I can keep on separate compute. With multi-warehouse writes, now you can also scale your data processing workloads, like ETL workloads. So an example could be you have large data processing jobs that you need to run once in the night. You need a bigger compute for it. But throughout the day, you have some trickle feed, some incremental data that is coming in. You need a different compute for it. And maybe a weekly or a monthly report that you need to run for which you need a different compute. Now with multi-warehouse writes, all this data, all these computes can operate on the same shared database. Another use case for multi-warehouse writes is live collaboration. So you could have different teams like sales, marketing, finance, data science teams, and they all need to collaborate on common data models like Customer 360 or operational logs. So now with multi-warehouse writes, everybody can operate in their own compute, but they can work on the common data sets. I briefly touched upon how important it is ease of use when it comes to scaling analytics in the organization. So we launched Serverless, Redshift Serverless a couple of years back, really to simplify working with Redshift. So with Redshift Serverless, compute is automatically provisioned. It is scaled automatically based on your workloads. And as a customer, you're really paying for what you use. So a simple scenario could be, I have some workload that is only 5 minutes, running for 5 minutes within an hour. As a customer, you're literally paying for that 5 minutes of compute. So the pay for use is pretty powerful with serverless. So we are continuing to improve Redshift Serverless. It is a very broadly, widely adopted feature. Some of the things, we launched serverless in 10 more additional regions. We added a number of functional capabilities like cross-region copies, snapshot scheduling, very recently private link support. So a number of capabilities to bring them in parity with the provision clusters. It also offers now 1024 capacity configuration. RPU stands for Redshift Processing Units, which means that you can onboard bigger workloads onto serverless easily. Another capability we are very excited to launch, this launched a week or so back, is now the AI-driven scaling and optimizations in Redshift Serverless is generally available. So with this, serverless Redshift is much more intelligent, much more dynamic when it comes to the compute. So as a customer, the way you work with it is pretty simple. So you get a slider. You can say, my workload, I want to optimize for cost. I want to optimize for performance. I want to keep it balanced and let the system figure out. And then serverless does the rest, right? So it is spinning up the compute. It is scaling the compute, deploying the optimizations to meet as well as maintain that performance level. One very simple use case for this is, let's say you have an ETL task. You have to process terabytes of data. You want it to finish in 15 minutes, 30 minutes of time frame. That SLA is very important for you. So this is an example where this particular feature could be useful. So you can say that I want a performance optimized setting for my workload, and serverless helps you to meet that performance level, but also maintain it as your data volume grows beyond what you are processing. So this particular feature has been in preview for a few months. We have multiple customers that tried out. This is one example where the customer has seen up to 5.3x better performance at only 70% cost. So this graph is indicating that after initially there was certain performance level, as the time passed, the performance significantly started increasing because of the ML-based optimizations. Along with performance, we have done a number of improvements on the observability, the ease of use. A couple of specific things I want to highlight. Now we have a query profiler. It's a nice graphical representation of the query execution plan. So you can take a look at it, analyze it, and debug any performance issues that you have. Another capability is query hash, which is a unique identifier for a SQL query, so that you can track the performance of a particular query over time to see if there are any recurring issues or patterns with certain queries. So pretty handy kind of feature with respect to monitoring the performance issues. So I talked a lot about the data sharing and serverless. I wanted to just kind of bring it to some specific real life customer examples. So Amazon.com is one of our largest customers for Redshift. So Amazon.com, the preferred choice for SQL analytics and data warehousing in Amazon.com is Redshift. So they have deployed data sharing and serverless at scale. So at this point, they have a set of 280 plus clusters that are serving as their producer, which means they are ingesting data, they're curating data, and they have around 2,500 consuming clusters that are consuming data from this. This is across 1,500 teams. It is mostly on serverless. A part of it is on provisioned, but widely used with respect to scaling their architecture. Another example is Getter, which is an ultra-fast grocery delivery company. They have democratized data access using the data mesh architecture with data sharing. And this helps them to kind of really improve cost efficiency, but also like deliver analytics much faster pace at scale. So they leverage data sharing heavily. They have some interesting statistics as well, terabytes of data, thousands of tables. And they also get a lot of messaging events that they need to process in minutes and sometimes in seconds. So data sharing allowed them to do workload isolation and also do chargeback to their tenant teams. Another example is Criteria, which is a talent management company. And they were using an alternative cloud data warehouse. That infrastructure is very underutilized and getting pretty expensive. So in this particular customer situation, they moved to Redshift Serverless along with Glue and Lake Formation as well as Lambda to set up a much simpler analytics architecture, which helps them significantly by reducing costs. The second pillar after the price performance is Lakehouse. So Lakehouse is a common term that is becoming increasingly common in the industry, in the space. So I just want to level set on what Lakehouse is. Lakehouse really brings the best of both data lakes, which is flexibility and the openness, and combines it with the data warehouse, which is the performance and the transactional capabilities. And as a customer, the benefit from the Lakehouse really is you're able to use your choice of engines and tools on all the data. You don't have to think about data silos. You don't have to think about the fragmented governance. So this is really kind of the promise of the Lakehouse. Some of you might have caught Matt's keynote today. Today, we are delighted to launch AWS kind of own unified, open, and secure Lakehouse capability. It's called SageMaker Lakehouse. So this is under the umbrella of SageMaker. We are bringing our analytics, machine learning, and AI services together into one umbrella. This is the Amazon SageMaker. So with the Lakehouse, really the benefit is we are bringing together the data that is there in S3 data lakes and Redshift data warehouses into a unified view. Many of our customers use both of them, right? They have data in data lakes, they have data in data warehouses. So with the Lakehouse, you get a unified view of it. The second part of the Lakehouse is open. So this data is available through Iceberg APIs. So any Iceberg compatible engine, it could be AWS engines like EMR and Glue and others. It could also be third-party engines that are compatible with Iceberg are able to get access to all this data, including the data warehouse data. And the third part is it has integrated fine-grained security controls so that you can consistently apply these permissions across all your data. And the nice thing with the SageMaker Lakehouse is it doesn't require you to make any changes to your data architecture, which means that any data that you have in data lakes and data warehouses is available as part of the Lakehouse. SageMaker Lakehouse is part of the broader announcement that has been announced today, which is the next generation of SageMaker. It has 3 components. Lakehouse is for unified data management. There is a unified experience. It's called Unified Studio, where all the data processing, SQL analytics, machine learning, Gen AI use cases, everything is in one unified experience now. You don't have to go to different tools. And then there is the integrated data and AI governance as part of the stack as well. So how does this actually work? So there are a number of components that contribute to kind of constitute the Lakehouse and the overall SageMaker next generation platform. Few things, now the Glue data catalog, which some of you might be aware of, is now evolved with a multi-catalog support, because now it is going to host not just data lake data, but also data warehouse data and a number of other data sources. Any existing data that you have in Redshift data warehouses, with a single click, you can publish it to the Glue data catalog so that the metadata is discoverable through a common catalog. In addition, if you are not a Redshift customer, you don't use Redshift today, you can actually build data lakes using Redshift managed storage, which is an analytics optimized storage. So we run the Redshift clusters behind the scenes to power these data lakes. Then you apply unified kind of fine-grained access controls, then you can access through any engine, which is Iceberg compatible. So in addition to this unified catalog, unified access, last year we launched an initiative called Trusted Identity Propagation, which is a unified identity across all the services. So with the Trusted Identity Propagation, you can come in a single sign-on fashion, let's say from Amazon QuickSight, and you go all the way through the stack, through the Redshift, through the lake formation, go to all the way to S3, and you don't have to re-log in, right? So the identity is really passed through the entire stack. This is a very powerful feature when you are deploying multiple AWS services together. So we have done a number of enhancements to the trusted identity propagation, like driver support, S3 access grants. So a number of new enhancements are done. But the idea is now, if you are trying to build a multi-warehouse architecture with Redshift, all you need to do is take your Redshift data, publish it to the Lakehouse. You are not moving the data, you're just publishing the metadata of Redshift. And then you can come in through another Redshift cluster and just start querying it. You don't even need to explicitly set up data shares. You don't have to worry about all the management. The Lakehouse simplifies how you can set up a multi-warehouse architecture with Redshift. So I talked about one part of the Lakehouse, which is how do we make the Redshift data and make it available broadly with the Iceberg compatibility. The second part of the Lakehouse is how can you use Redshift as a powerful SQL engine on top of the data lake data. So Redshift always had open formats support. Recently, we have introduced Iceberg support. So if you have data in your data lake in Iceberg format, you are able to query it using Redshift. And you can join it with the data that is there in the warehouse. We have done a number of enhancements on the data lake performance, up to 3x better performance when Redshift is querying the Apache Iceberg formatted data. One of my kind of favorite features is now we have incremental materialized views on data lake tables, which means that you might have a data lake data, everything in open formats, but you need to power a high performance dashboarding application. You can go and build a materialized view, point to these data lake tables, and then you can get your kind of few seconds response times queries. So pretty powerful feature to enable interactive analytics on data lakes. Moving to the third pillar here, which is simplifying ingestion and near real-time analytics. We have been working on simplifying ingestion in the past 12 to 18 months. We have a capability called autocopy, which is now generally available. So autocopy is a simplified automated ingestion from S3. So as a customer, you would just set up saying my source is this S3 bucket, my target is this Redshift table, and we automatically continuously load the data. So we detect new files, we take care of what has been ingested, and make sure that it's ingested only once. And as a customer, then you don't have to worry about setting up these copy commands, scheduling them, tracking what files have been ingested. So no need for any custom solutions. The continuous ingestion capability in Redshift takes care of it. This is from files. We also simplified ingestion from streams. Our streaming ingestion launched almost 2 years ago at this point. This is a very, very widely adopted feature. With streaming ingestion, you can bring data from Amazon Kinesis or Amazon MSK, Managed Service for Kafka, very easily into Redshift without staging the data in S3. So you just set up a materialized view in Redshift, you point to a Kinesis stream or a Kafka topic, and the data automatically loads into Redshift as soon as there is any new streaming data coming in. So we have a lot of customers that are using the streaming ingestion. As I said, pretty high throughput, low latency ingestion. We improved the multiple capabilities on the streaming ingestion, more scalability. We added things like MTLS authentication, resiliency. One of the recent features launched a couple of weeks back is now we go beyond the Amazon streaming services. We are supporting Confluent Cloud as well as self-managed Apache Kafka clusters. So you're able to ingest data from these environments very easily into Redshift without having to build any pipelines. Streaming ingestion is used by a lot of customers, a combination of use cases. One is simplifying ingestion, and the second one, more common one, is really near real-time analytics at high throughput. So I covered briefly kind of the simplifying ingestion from files and streams. The next kind of source, common source, is databases and applications. So this is where our Zero-ETL vision comes into the mix. With Zero-ETL, the idea is to provide an easy and secure way to bring data from operational stores so that you can do near real-time analytics on the transactional and operational data. So we started the Zero-ETL journey with Amazon Aurora MySQL. At this point, we have MySQL, we have Aurora PostgreSQL that is generally available. We have launched Amazon DynamoDB, which is generally available. RDS MySQL is available. Today, we launched Zero-ETL from enterprise applications like Salesforce, Zendesk, so 8 sources. These are available with Zero-ETL into Redshift. So it's a pretty straightforward feature where you set up your source, set up your target, and the data lands in Redshift. We have also worked on a number of what I call in-depth, kind of depth features of Zero-ETL, so things like data filtering. You don't want to bring your entire source database into your data warehouse. You want to selectively pick and choose things. We worked on things like monitoring, enhanced VPC routing, so a number of enterprise capabilities to help make Zero-ETL into production. A lot of customers started rolling out Zero-ETL into production. One example, Pionex, which is a cryptocurrency exchange company. They use both streaming ingestion and Zero-ETL, and they were able to bring down the latency from 30 minutes to nearly 30 seconds. So it's a huge improvement. And also it takes away the cost with actually putting together the pipelines, managing the pipelines, so significant reduction with operational costs. Finally, the next pillar. So we have a lot of announcements coming up on generative AI tomorrow in Swami's keynote. A couple of things I will share, but you will hear more soon. The first, the generative SQL capability in Redshift Query Editor is now generally available. So this is a natural language way to express queries and get back the SQL recommendations. So you don't have to understand kind of the organization schema, metadata, the complex technicalities. You can just interact with your data using natural language. It also considers your permissions that you have. It also makes sure that it considers the query history so that you are getting much more accurate recommendations from the system. Another new capability we launched just in the last month is Redshift integration with Bedrock. So here there are a lot of foundational models that are out there, like the Claude, Mistral AI, and Amazon Titan. So what you can do now is simply create an external model reference in Redshift to point to these foundational models, and then you can just invoke them as part of your SQL for inferences. So this is directly executing things like sentiment analysis, text summarization. So all these things you can do it in SQL and make these generative AI capabilities part of your analytics workflows. So I talked about a number of capabilities. I just want to kind of show a couple of them through a quick demo. So the demo that I'm going to show is a comprehensive analytics for a retail company called Any Company. So this is the new announcement today, Unified Studio, Lakehouse. This whole thing is part of the SageMaker platform. So I am coming in, logging into the Unified Studio. So Any Company has a domain here. So I go ahead and log in into this domain using a single sign-on fashion as a user. I see my projects. I'm logging into the data analytics project for which I have access to. And in the project, there is the data that is there in the Lakehouse. To start with, this Lakehouse essentially has default catalogs, which has open source kind of S3 data that is there in my data lake. So what I want to show is if you are a customer that has Redshift data in it, how do you make it part of this Lakehouse? So this particular company, Any Company, has multiple business units. They have sales, they have finance, they have CRM, they have 2 data warehouses, Redshift. One, sales. The second one, a combined data warehouse across their finance and CRM teams. Now I want to take this data, publish it to the Lakehouse. Publishing the data to the Lakehouse is a pretty straightforward step. You just register with AWS Glue Catalog, which evolved as the Lakehouse. So you simply register, it's one step. Then I'm doing the same thing for the finance and the CRM data warehouse, so registering it. Once I register it, I go to the Lake Formation console, and I want to create catalogs associated with each of these Redshift clusters. So I have now a sales catalog that I'm going and creating. Then I want to create my finance and CRM catalog as well. So essentially what we're doing is registering the Redshift data warehouse metadata into the Lakehouse. We are not doing any data movement in this particular flow. So as you can see, we are seeing the two catalogs. I want to go ahead and give permissions to my Unified Studio users. I can do that using the Lake Formation permissions. For simplicity, I'm doing the super user, but in reality, you can do all fine-grained access controls of Lake Formation, like row level, column level, cell level controls. So I have published my data from Redshift. I have set up the permissions on the catalogs in the Lakehouse so that I can make it accessible from the Unified Studio environment. Now I go to my Unified Studio. I go ahead and refresh my Lakehouse catalog. So whatever the data that is, whatever the catalogs that are published to the Glue data catalog, now they just appear as part of the Lakehouse. So as you can see here, essentially the Redshift data warehouses are showing up as part of your Lakehouse hierarchy, data catalog hierarchy. So the data warehouses don't have any data yet. So I'm going to use Zero-ETL integrations to populate some data into my Redshift data warehouses. The first Zero-ETL integration I want to create is for my data from sales, which is there in Aurora Postgres. So I go to my RDS console. I'll go ahead and start creating a Zero-ETL integration from Aurora Postgres into Redshift. So here I'm selecting my source Aurora database, and then you can filter what exact data that you want to bring from your source system. And you can choose your target Redshift data warehouse, which is sales in this case. I can go ahead and create my Zero-ETL integration. So from the Aurora databases, RDS databases, Zero-ETL integration is near real time. So when I go and see the table statistics, I have 4 tables that are replicated from Postgres, and I have around 200,000 rows, 600,000 rows. So it's a near real time replication, so the data continuously changes. And we have a lag of around 6 seconds. So across our fleet, we have 8 seconds lag for Aurora Zero-ETL. So now I go back to my Unified Studio, and when I refresh the sales catalog, now I see the data that I got in through the Zero-ETL. All the 4 tables that are ingested through Zero-ETL are here. So the nice thing with the Unified Studio is all this data is now queryable by different engines. So I could query it using Athena, I could query it using Redshift, I could query it using Spark. So I want to kind of showcase a couple more Zero-ETL integrations. So I have my additional data. For example, my payments data is in DynamoDB. So I'm creating another simple kind of Zero-ETL integration from DynamoDB. So I pick my payments data, and I select my target Redshift warehouse, which is the finance, and I go ahead and create my Zero-ETL integration from DynamoDB. So this is bringing in the payments data. So once we have the data, same thing, you can check out how many rows have been ingested from DynamoDB. And finally, the last Zero-ETL integration I want to show, which is new, is the Salesforce integration. Salesforce integration is coordinated by Glue. So you go to the AWS Glue console, you can pick your Salesforce as the source, and you can pick specifically what objects you want to bring from your Salesforce system. I'm bringing in customer, organization, and I can go ahead and finish my Zero-ETL from the Salesforce. And this data is also going into the finance and the CRM, the second data warehouse that I talked through. So we finished, basically we have done 3 Zero-ETL integrations so far. And once the Zero-ETL integration is finished, I can go back to my Unified Studio, which is again the combined kind of studio for all my workloads. And once I go and refresh this particular Lakehouse catalog, now I start to see the data even in the finance and the CRM catalogs. So note that I'm not moving any data. The moment you register Redshift with the Lakehouse, all the new data in Redshift appears in the Lakehouse. So through the Unified Studio SQL Query Editor, I can start doing SQL queries. For example, I'm querying my payment data that came from the DynamoDB. Another thing I could do is I can just ask questions in the query editor in the natural language, like which product has highest sales. I get the SQL, and I use that to kind of simplify how I do queries inside the studio. And one of the key things that we talked about for the Lakehouse is the Iceberg compatibility. So now this data that we just ingested is also immediately accessible by Spark. So I'm opening a Jupyter notebook, and across the two Redshift data warehouses, the sales catalog and the finance CRM, I'm able to do a query for customers with outstanding balance. So I'm literally doing query across two data warehouses data using my project Serverless compute. And this is the Spark, so pretty easy to consume the data through Spark as well. So finally, I want to go back to my SQL query editor, very quickly show how you do kind of sentiment analysis with Bedrock integration. So here I'm using kind of the Anthropic cloud model, and then you just create an external model reference to it. I get a function back, and I use it as part of my SQL query for identifying sentiment. So the nice thing is the data is still in Redshift, but it is available through Lakehouse for other engines like Spark, Athena, or any third-party engine to be consumed via Iceberg. And the other part is this experience is everything inside this unified studio, so you don't have to go to multiple tools to put together things. So with this, I'd like to hand over to Ronnie to walk through Charter.
Thank you, Neeraja. Good afternoon, everyone. I'm Ronnie James, Senior Director of Business Intelligence at Charter Communication. Today, I'm excited to share with you all our data warehouse platform migration to Redshift. We'll start with a quick introduction to our company, our business intelligence team at Charter, our legacy platform and its challenges, our assessment for a future state platform, and our migration to Redshift. We are Charter Communications, a connectivity company for everyone. Many of you have heard of us as Spectrum. Through our Spectrum-branded connectivity products, we serve close to 31 million customers in the United States. We are one of the largest cable operators and a fastest-growing mobile provider in the United States. We operate in 41 states with connectivity services to 58 million plus homes in the United States. Our business intelligence team is responsible for building and maintaining a single source of truth of key operating metrics for company operations as well as our labor effectiveness. We build trusted reports for various business units. We curate data as products for their operational and analytical use cases. So we organize different data sets in a timeline of business event for our journey analytics. We do all of it through our governed platform, and we make sure all of these products, these data services are secured as well as standardized for all of them. To help you all understand our scale of our environment, we have few data points here. On a daily basis, we source data from 200 plus source systems. And we execute more than 500,000 queries and organize the data in a central data platform. We have close to 5,000 plus reports which uses the central data platform and provide actionable insights to our various business groups. We have 25,000 of our business users who uses these reporting products. These users varies from store, call center, and field level agent to their supervisors. The same central data is also shared for our executive as well as external reporting. We believe in bringing use case to the data. We have, through our shared analytics platform, 1,000 plus direct database users from various business units who does their department analytics. Our legacy platform evolved over the last 14 years. We ingested data from various source systems. We built many custom solutions for our metadata management, log management, and the key management. The center of the platform was an MPP technology. The MPP technology managed various workloads. We experienced many challenges in this legacy platform. Due to the shared nature of the legacy platform architecture, when our batch loads were happening, we restricted the shared analytics departmental use cases. Our reporting users, we limited them when there is batch delays or upstream delays happened. Our data quality jobs have to wait for SLAs to complete, and our proactiveness on data integrity was challenged. All these issues continuously challenged our resource contention in the central data platform. Scalability was another key challenge that we experienced. It required months of procurement to add compute or storage. Another key challenge that we experienced was poor disaster recovery. It required weeks of RTO and RPO in our legacy platform. To address these platforms, we originally migrated it to legacy technologies, cloud-based solutions in 2022. We continue to experience these challenges in the cloud-based solution as well. And we observe that the cloud-based solution retained all these challenges, and we started experiencing an increased operating cost due to the usage-based pricing model. The challenges really limited our agility. To address these challenges and to improve our agility, we started our modernization journey through a three-pronged approach. We started our assessment in Q2 of 2023. We identified the market leaders, assessed our workloads, and piloted them for an apples-to-apples performance comparison. We have a summary of our performance comparison in the following slide. Once we concluded the assessment, we created our business case for the migration. With the leadership approval in Q4 of 2023, we started our migration to Redshift. We selected our SI partners, and we converted the code, did the history data migration, and we completed the cutover migration. We completed all of this migration in 10 months' time. And with the migration behind us, we are continuously working towards modernizing our platform for better data sharing and faster data insights. During our assessment, we selected 4 key market leaders in the space. We selected our workloads across extract, transform, load, and reporting of various sizes for the assessment. The chart here shows a summary of our comparison results. Through our comparisons, what we learned is Redshift RA3 architecture provided the fastest and 20 to 30% price performance for our workloads. Another option we considered, option B, had better features but no specific price performance improvement for our workloads. So we concluded our migration knowing that the Redshift provided the fastest performance for our workloads. Redshift also provided immediate storage scaling, and it had variety of compute options for our various workloads. Redshift also provided very simplified native integration with many AWS services. It also ANSI compliant. Since majority of our code base is SQL based, it was easy for us to migrate from the legacy platform to Redshift. All of these were strategically aligned with our business objectives as well as our technical objectives. We started our migration in October of 2023. The foundation phase, we segmented the project into 5 phases for tracking, prioritization, and ease of communication. In our foundation phase, we really focused on building our infrastructure, making sure our security guidelines are in place, and started building accelerators and automations for our migration. In the data sourcing phase, we focused on our data ingestion piece as well as data curation within our producers. In the data publishing phase, we focused on our reporting and data products that provided to our downstream consumers. On the phase 4, we executed all of it in parallel with our legacy platform and tested to make sure all of our KPIs are 100% matching. And finally, at the phase 5, we completed the migration with a big bang approach. Throughout the migration, we decommissioned a lot of legacy code that's not heavily used. We also, partnering with AWS, built many training materials and ensured our labor or our data workers are trained to support our workloads in Redshift. There are 4 key accelerators that helped our migration to be successful in 10 months' time. First and foremost, automation. We built automation across many labor-intensive and many labor-intensive as well as very repetitive tasks across our project migration lifecycle. We'll cover a few more details of that in the following slide as well. We built self-service. As many of you know, the environment that evolves over the last 14 years with 1,000+ users. Many users had SQLs stored in their local machines. We provided the self-service portal where they can upload their SQLs and they'll get a converted code in 10 minutes time, within 10 minutes time in their inboxes. This was really helpful for them to convert all their legacy code that's stored locally in their machines. Persona-based training was another key accelerator for our migration. Partnering with the Redshift team, we built training for admins to analysts and made sure these trainings are with very specific hands-on experience. We did these trainings in person as well as remotely. We also made sure that these trainings are available through our university for self-paced training for our team members. Finally, a unit testing strategy, T1, T0. We kept 2 consecutive days of snapshot of data in Redshift. Sourcing from day 1 data, pointing our target to day 0, we executed the jobs to make sure all of the data, row by row and column by column, are matching 100% for the day 1 targets. This has really helped our unit testing to be 100% accurate. And if there is any differences, they were able to clearly document and educate on those differences. In our migration lifecycle, we extracted the code from the legacy platform. Using an enhanced version of SCT, we converted the code. The converted code is then deployed in the Redshift development environment. The developers use the T1, T0 strategy and the converted code to complete their testing to make sure we validate all the data points. Finally, the converted tested code is continuously deployed in our production environment. The first set of automation was in the code conversion. Partnering with the SCT team, we enhanced the SCT code conversion outcome for our standards. And they also partnered with us to improve the SCT's efficacy from 65 to 95%. We also built auto data migration frameworks. These frameworks helped us to migrate 400 terabytes of data on a weekly basis from our legacy platform into Redshift. We also use the data migration framework for our integration testing as well as our final day cutover migration. We had auto code deployments. All the converted code tested in the development environment continuously deployed in our production environment. We had auto code monitoring because our business was not stopping during the 10 months of time. They continues to make changes in the legacy platform. So the auto code monitoring helped us to identify the changes that's happening in the legacy platform and include them for the future iterations. Finally, an auto integration testing. All the code that converted, tested, and deployed in the Redshift production environment, we compared the test results of this with the legacy platform data on a daily basis. We built dashboard that helped us to point to any areas where there are issues. All of these automations were the backbone of our migration. In our new data platform, we aligned our architecture with Redshift hub and spoke architecture. We continue to ingest data from all these various source systems. We integrated better with AWS services for logging as well as for key management. In the Redshift, we have the ETL cluster, the batch cluster, as well as our NRT cluster acting as the producer hub. All our workloads on the consumer side are the shared analytics, reporting, and data quality. These consumer clusters in the past where they experienced many technical challenges during our batch loads. Today, our shared analytics users can continue with their departmental analytics when the batch loads are in progress. Our reporting users don't have to stop when the delays happens on the batch loads. Our data quality can be proactive and continuously run in parallel with our batch loads to make sure we are proactive on the data integrity validations. We were also able to onboard new use cases very quickly. For ad hoc analytics, we onboarded Redshift Serverless and started sharing the data, and they were able to start using the platform in less than 24 hours. Finally, we were also able to share the data with our development environment. The developers are able to use the production quality or production data itself for doing the new development. It significantly reduced the iterative testing that they do in the development environment and built really good products at the first time itself. The migration to Redshift has significantly addressed all our technical challenges. We are seeing an 18% on our SLA products due to the workload isolation. We are seeing less than 24 hours to scale any new platform. That's also just for internal approvals. Our disaster recovery now have less than 24 hours of RPO and an 8-hour RTO. Redshift is continuously evolving. All the features that Neeraja just mentioned, they're continuously releasing on a weekly basis. So we were able to use those and continuously evolve in our architecture. Finally, we reduced our operating costs by 35% each. Throughout the migration, Redshift technical features that they released in the previous quarters, as well as the AWS team, have played a significant value addition. The data sharing, Amazon Q, Generative SQL, scope permissions, and Redshift Autonomics, some of the key features that helped us to complete this migration. AWS contributions, there's no words to thank. They were the best partners that you can have in a large-scale migration like ours. SCT team continuously worked with us to enhance the SCT product. The solution architecture team, on a bi-weekly basis, conducted reviews and made sure our components are built and well-architected. The performance tuning helped us to address any of the key performance area concerns. The product team continuously heard our feedback and included the necessary features to support our needs in very short time. Any large-scale data migration is not going to be without challenges. Some of the key learnings that we had that we want to share with you all is make sure when you design to distribute your workload across many clusters in Redshift architecture. If you have large, wide tables with columns more than 1,000, make sure to use the pre-warm global cache to reduce the compile time issues. If you are converting from a platform that has code page differences, make sure you understand the differences between the character sets and communicate ahead to your consumers on the non-differences. If you are using SAML or SSO integration, make sure to evaluate that as early as possible. There are three key success contributors when we look back on our migration completion. Building a robust inventory and aligning it with our SMEs was the key foundation for our success. Our business intelligence team at Charter played a pivotal role here. I want to give them all a big thanks. Accelerators and automations were the backbone of our migrations. They really helped us to complete this migration in 10 months' time. Collaboration with AWS and partnership with our SI vendors, Infosys and DataFaxi, helped us to execute this project on time successfully. Finally, our modernization has not stopped here. Redshift migration helped us to reinvent our data platform for future data strategy. We want to integrate open source formats for our improved data collaboration. We want to integrate BI for AI for BI for improving our SDLC and faster insight into our data products. Many of the features Neeraja just announced, SageMaker, Lakehouse, data sharing rights, all of them are clearly in line with the strategies that we want to move ahead with. As many of you, we are all excited to start using these features as soon as they are available, as soon as they are generally available. With that, I want to conclude and hand it over to Neeraja for the final words. Thank you.
Thanks, Ronnie. So we'll wrap it up. I think just a summary, Redshift delivers superior price performance, and the data sharing, the combination of data sharing and serverless is a powerful mechanism to scale your deployments. And with the Lakehouse, you can leverage Redshift data more broadly across the organizations, and near real-time analytics is a focus, and you will hear more about the generative AI announcements. So with that, I'll take a couple of questions for me or Ronnie, and then we'll do offline conversation.